My name is Ipsa, and today we are taking the topic in physics, where we'll be calculating power, where the circuit contains a combination of parallel resistances and series. It's not a purely resistive circuit, and it is not purely it's not purely a series circuit, and it's not purely a parallel circuit. It's a combination of parallel and series. Okay. So in such circuits, whether we have to solve for voltage or for current or for power, what do we have to do is first simplify into either purely resistive. The first step is always simplify in either purely resistive, purely series or purely parallel circuit. Okay. So first let's identify what kind of circuit it is before even reading the question. Okay. We have two R1 and R2 in parallel, and there's one R3 which is lying there. So let's understand the circuit first. What do you think? Which two resistances, like in the previous video I explained, are holding left in left hand and right in right hand? If you observe carefully, these two resistances are holding left hand to left hand, see here and here, and right hand to right hand. So this makes it very clear that R1 and R2 are in parallel. Now what we can do is combine these two circuits, these two resistances into one single resistance. As in, we can simplify this circuit into this continues to be R3, which is 4 ohms, this one. But what is this? This is the simplified version of these two resistances. Let me repeat, whenever we have a combination of parallel and series, we have to convert it into a purely series or a purely parallel circuit. So because we identified this as a parallel combination Rn and R2, we changed Rn and R2 into something known as maybe R5 value we will find out. We changed into something known as R4, and the moment we changed this section into R4, it became a purely series circuit. That is the first object. Okay. Once we have a purely series circuit, then it is easy to solve the circuit. Then we've studied also how to solve the circuit. But how to do this? How to convert a combination circuit into a purely series circuit? We have R1 and R2 in parallel. Do we know how to convert two parallel resistances into a single resistance? Yes. If we have two parallel resistances, we know how to convert it into a single resistance. Okay, so let's find the value of R4. R4 is nothing but a conversion of these two parallel resistances. So how much is R4? So the first step is to find the value of R4. R4, if you take the anomaly from here, will be what? R1, R2, R1 plus R2. Replace the values. We get the value of R4 as 2 ohms. The moment we have it, the circuit gets simplified into this one. Right? Now we have a simple series circuit, and we can go ahead further into what the question demands. Alright? Now we make a table. Now once we have a simple circuit, now we start making a table. We have these simplified this circuit. Now I'm making a table. We have two resistances, so we make three columns. One is R4, one is R3, and one is R total of these two. Remember? You remember we used to make this table when we had a simple circuit? Okay. How do we carry on? We write all the electrical things under it, which is V4, I4, power 4. Here it will be V3, I3, power 3. Without even reading the question, we just write these variables. And this is V total, I total, and power total. They're not even seeing what we need, what we don't need. We just make this table for simplicity of calculation. Now from here, we forget this completely for a while. All this we completely forget for a while. I'm standing here so that you can't even see it. We are considering these two. What all do we know from here and in this table? Right? Right? We don't know this. This is V total, right? The total supply voltage is also known as total voltage. So we write it here. It's a series circuit. Now how do we fill it in? We have a horizontal column, horizontal something where we have two values, and it's a series circuit. Can we add them up to get R total? Yes, we can. A series R total. First step, R total will be R4 plus R3, which gives us so this comes to be 6 ohms. What are we interested in? Let's see. Find the current in R1. We don't even have R1 here. Oh God, we don't have anything here. Sure. Let's focus on this, because whatever they have asked R1 and whatever they have asked R2 was a part of this. So we'll try to find everything related to R4. You understand why? Because R4 is what contains R1 and R2. See, so this is what we are interested in. Okay, how do we find this? Okay, look at the series section. It's a series section. Whatever I total flows here, same flows here in R4 also and in I3 also. Can we find? Yes, I can find I total, because we have two things here, right? So the second step is simple Ohm's law. And we get that the total current is 2 amperes. I simply applied Ohm's law in this vertical column and I got it as 2 amperes. Now if I observe from this, sometimes you have to observe, sometimes you have to observe the table, sometimes the circuit. Now if this is 2 ampere, how much is I4 going to be? I4 is what is entering here. It's also going to be 2 ampere. जितना करंट यहाँ से निकलेगा उतना ही तो यहाँ जाएगा, उतना ही तो I3 में जाएगा. So this is also 2 ampere, though we not bother about it. Okay. The focus was on this. Remember? क्यों? क्योंकि हमें सब कुछ R1 और R2 का फाइंड करना था. इसलिए the entire focus is on R4. वो हमें ये पता चल गया. Can I apply Ohm's law here? दो चीजें पता है ना हमें इस vertical column में. Now I am applying Ohm's law to this vertical section. V4 is equal to I4 R4, R4, V4, am I clear? I just applied this and I got the value of V4 means what? The voltage here is 4 volts. Okay. Now what? Let's come back to the original circuit. Okay. Here the voltage is 4 volts. Does it not mean that here also, here, the voltage is 4 volts? This was what? This was just a recreation of these two resistances. That means here also the voltage is 4 volts, here also voltage is 4 volts, and here cross side is also 4 volts. Right? So here we have 4 volts, here we have 4 volts. Now what do? I need some space. I will run this off. And coming to the next step. Here what is the voltage? 4. What do I want? Current is R1. I want I1. Right? I want I1. What is V1? Is R1. Can I apply Ohm's law? So I have satisfied the first answer. I have solved the first answer, that the current in the first resistance is 4/3 amperes. The second question is, what is the power in R2? Okay. Let's see. Power in R2, which means I want R2. What do we have? We have R2, we have V2. Do we have V2? Yes, we have V2. This is the V2. Which formula can I apply? Power. We have R2 and V2. R2 V2? No. R2 V2? Yes. I can apply this formula for the power, and power will be V square upon R. But इसी का power means R2, इसी की voltage V2, इसी का resistance R2. Right? This is what we are interested in finding out. This is how much? 4. R2 is how much? 6. What do we get? 16/6. So we get that power across the second resistance is so we have solved both the circuits, both the questions, and I understand this is slightly complicated, but I will make one more video on a similar question and we'll get to see how to do it again. Similar question, not very simple. But just first step, you try to remember that a complicated circuit has to be converted into either simple series or a simple parallel circuit. And then boom, table wise. Alright? Thank you.